this is the system here. This is initial stage. This is the initial stage. This is the final stage here. How the system changes here? Because you are providing here the heat energy that generated by the Q here, and due to that heat energy, this is the piston here. That molecules, all the gas molecules, that will receive the heat energy, and after receiving heat energy, the pressure is increases there. Due to increase in pressure, that piston will be moved upward here. So this is the case here. Now in initial stage, the piston, the place of piston is here. But when amount of heat energy received, the gas molecules receive energy and they get they exert the more pressure. Due to that pressure, that piston will be goes upward here. Therefore now the piston is here. So this much amount is of this work has been done there. W is the work done here. So this work is done here. Now here the system is having the pressure P1, volume P1 and temperature T1 here. This is the pressure, volume, temperature of this initial system here. Then when this work is done there, when the piston moves upward here, then its pressure is changes from P1 to P2. Its volume is also changes from P1 to P2 because the heat energy received, pressure increases here. So therefore pressure P1 changes to P2 here. Now this is the volume P1, but here volume is increased here. So therefore volume is P1 here, but the temperature is not changes here. So this is the common factor in temperature. Initial state में pressure is P1. In case of final stage, also temperature is P1 here. Therefore, temperature is constant here. And when the temperature is constant here, so there is no change in heat energy. No change in energy. No change in energy here. This is the logical sentence here. If the temperature is constant here, then therefore no change in energy here. Therefore its internal energy is U here, and here internal energy is also U here. Why here is U1? Why here is not U1 and U2 here? Because temperature constant, so no change in internal energy. But in this system also the energy is U. In this system also the energy is U here. Means delta U is equal to 0 there. Then whatever the amount of heat energy is received, then what is the use of that energy here? Because if the heat energy is received here, then that should be stored in the form of internal energy. But here internal energy is constant here. There is no change in internal energy. That shows that whatever the amount of heat energy is received by the system, that totally converted into the work done. Means here the Q is equal to complete W here. Then what is the isochoric here? Now this is the pressure of the isochoric here. Now here the pressure is P1, volume is P1 and temperature is T1 here. Then when the system changes here, because here the amount of heat energy is received from the outside. So this is system here, and here energy which is coming from the outside, that is this is surrounding. We are taking energy from surrounding here. Then due to receiving the amount of heat energy, what will changes there? The pressure from P1 to become P2 here. Then for loop will select on the temperature will become P2 here. Now look at in this external process here, the piston is here, and in final system the piston is going upward here. So actually this is also replacement of isothermal process, but here the piston is here, and in final system also the piston is here. Means the work done is zero there. So not type of work has been done there. Then this is the internal energy U1. The question is here, if the work is not done there, means this volume and this volume is same here. Therefore, there is no change in volume. Initially, the volume is V1. In final, also the volume is volume is also V1 here. Then question is here, if the work is not done here, then the amount of heat energy which is absorbed by the system goes here. Then that amount of heat energy is only stored in the internal energy. Therefore, internal energy at the initial stage of U1, and after receiving the heat energy, that energy becomes the U2 here. Only that amount of heat energy which is received from outside is only stored in the form of internal energy, but work is not done there. Therefore, that amount of heat energy is only equal to delta U here. Okay. Then the third process is the isobaric process here. Now this is the third process, what is the isobaric here. Now bar, just consider the bar. Bar means here that is the unit of pressure here. That pressure that we use in with the help of barometer here. I can say its pressure is P1, volume is V1, temperature is T1 here. Here the pressure remains constant here, P1 as it is, volume increases here, temperature is also increases here. Now see here, at the initial stage the piston is here, piston was here, and at final stage the piston is here. Therefore, there is a movement of piston here. If the piston moves there, that shows that the work is done there. I will give you amount of heat energy here. So its internal energy is U1 here. The amount of heat energy which is received by the system here means by this gaseous molecules, that molecules will become excited here with having the random motion that will be touched to the lateral wall as well as to the surface of the piston here. Therefore, as the gas expand here, create the high pressure, so this will go upward here, means work is done there. But that is possible only due to receiving the heat energy. Then we can write here the amount of heat energy is received is equal to here the delta U plus work done. What happened here? इथे work पण झालेलं. In short, suppose if the 100 energy is received by this initial stage here, out of that 70% is converted into the work done, and remaining 30% is stored in the internal energy, so it will become the U2 here. Therefore, we can write here the amount of heat energy which is received from the surrounding. Out of that energy, some energy is stored in the form of internal energy, and remaining energy is utilized to perform the work, or that converted into the work here. Then fourth is here the adiabatic. Now this is the adiabatic process here. Now again here the pressure is P1, volume is P1, temperature is T1 here. And now see here the process is adiabatic. When the process is adiabatic here, that will not receive heat energy as well as not release the heat energy. That in last video we have learned the isolated system. That in isolated system here the heat is not taken inside or heat is not given outside here. Like for example we have learned the thermostat here. In the same sense here, in this adiabatic process, no heat energy is received from outside here. So that is completely zero here. Now in all the process here we have learned the amount of heat energy received, work is done. Then amount of heat energy received, the work is done. The amount of heat energy required, work is not done, but that is stored in the internal energy. So in all the three processes, isothermal, isobaric and isochloric process, in all the three processes we have taken the heat energy and we have utilized that heat energy to convert it to the work remaining to store in the internal energy. But in adiabatic process here, no heat energy is taken from the outside here. Then the work is done. Just understand here, in all the three processes, isothermal, isobaric, in isochloric process, in all the process, if the work is done, that is only due to the amount of heat energy is received here. But here, even though the heat energy is not received, but the work is done there because the piston was found here at the initial state, then in the final state, the piston found here. So this much amount of work is done there. Then how the work done here? Because if the heat energy required, the work will be done. But here if heat energy is not required, then how work is done here? Then if the amount of the internal energy is here U1 and internal energy is here U2 here. Here work is done by the internal energy. Suppose if the system has 100 rupees here and this out of 100 rupees here, suppose 70 rupees these are utilized for the work here, then 30 rupees will be remains. This is just for example for better understanding here. Means the value of U1 is 100, the value of U2 is here 70 here. We have to focus it on that the amount of heat energy is absorbed, is received is 0 here, but work is done there. That work done is with the help of its internal energy. That is whatever the energy was present in the store form, that energy from the store form is being utilized to do the work here. Therefore, delta U is equal to U2 minus U1. But here the value of U2 is smaller, and the value of U1 is larger here. Therefore, the delta U, its sign will be minus sign here. And in this way, the work is done here. That work is equal to minus change in internal energy. The minus sign is here because generally, if the U2 if the U2 was bigger and U1 is smaller, at that time there is a plus sign. But here, initially the internal energy was found to be larger, and its energy is used to convert to work here. Therefore, at the final stage, the energy will become less here. Therefore, from the smaller quantity minus larger quantity, it will show the negative sign here. Therefore, change in internal energy will be shown by negative sign, and here no heat energy is absorbed here. Therefore, only the work done, that is equal to the minus delta U. So in this way, this is something about the isothermal process, then isobaric process, isochoric process, and adiabatic process here. So once again, just reminder here, in isothermal, the temperature remains constant. If the temperature remains constant, there are no change in internal energy. Due to the not change in internal energy here, work is done there. The total amount of heat energy received is totally converted into the work done here. In case of isobaric here the pressure remains constant here. Therefore, whatever the amount of heat energy received, from that heat energy, some energy is used to convert into the work here, and remaining energy is only stored in the internal energy. Therefore, Q equal to delta U plus W. In case of this isobaric process here, the piston is here, so no movement there. Therefore, there is no found work is zero here. Then even though the work is zero here, then what amount of energy is received from outside? If that not used to convert into work here, then that is used to store in the internal energy. And therefore, that heat energy Q equal to minus delta, that is change in the internal energy. And finally, that is adiabatic process here. Its characteristic is that it is not receive the energy from surrounding, or will not give out its energy to the surrounding here. Therefore, the role of heat energy is cancelled. It is equal to zero here. But even though the work is done there, means that whatever the internal energy is present in the system, that is used to convert into the work here. Therefore, the internal energy of the initial stage system was larger, and due to it spends here to do work here. Therefore, the energy in the final stage remains less here, and therefore, if you want to calculate the change in energy, then that instead of to become the U2 minus U1, you have to make the expression U1 minus U2 here. Therefore, the sign is negative here, and here Q is 0. Therefore, only work done is equal to the minus delta U. So in this way, this is something about the processes in the thermodynamics. Thank you.
जवाहर कला विज्ञान व वाणिज्य महाविद्यालयातील सर्व विद्यार्थी बंधू भगिनींना विनंती की कोरोनाच्या पार्श्वभूमीवर आपले अध्ययन ऑनलाईन पद्धतीनं सुरू होत आहे, तेव्हा या ऑनलाईन पद्धतीच्या अध्ययनामध्ये आपल्या प्राध्यापकांनी आपल्या विषयाच्या व्याख्यानाचे व्हिडिओ करून ते ई गुरुजी या चॅनलवरती अपलोड करीत आहेत. तर तेव्हा सर्व विद्यार्थ्यांनी ई गुरुजी चॅनलला सबस्क्राईब करा आणि लाईक करा.